Welcome to the AI Ireland podcast, your window into the world of AI innovation on the island of Ireland. Join us as we explore how AI is harnessed to tackle both business and societal challenges, revealing the cutting-edge solutions emerging from this vibrant AI community. Don't forget to subscribe for the latest updates and insights in the world of AI. Hello everyone, it's Mark Kelly here, founder of AI Ireland, and today we are joined by Jeremiah Scully. Jeremiah is an AI R&D engineer at Moofwd, and he today is going to share a little bit about his application within the neural networks project where that he pursued as a PhD, which is applying AI to solar physics. He's developed an innovative solution for solar weather detection and manufacturing quality assurance, and he is a nominee for this year's Young AI Role Model of the Year. Jeremiah, thank you very much for joining us on the podcast today.
Hi Mark, thanks for having me. So a bit about myself. So as Mark said, my name is Jeremiah Scully and I'm an AI R&D engineer at Moofwd. So Moofwd is a tech solution company, specifically within the edtech and fintech sectors. So my role actually involves obviously the research and development side of things. There's consultancy and implementing AI-driven solutions that solve essentially business challenges. Kind of my everyday work would involve exploring new AI technologies, designing algorithms and integrating AI models into essentially existing pipelines. So stuff, majority of customers that come to us essentially don't have AI solutions with them, and they kind of want to explore the options of how they will integrate AI technologies with it. Just from a business aspect, I've about 3 projects currently going on at the moment. It's within the role itself. There's a lot of freedom to explore different AI technologies and try and integrate different sort of solutions to different problems. So I've essentially within Moofwd, there's three projects ongoing at the moment. So the first one being on the edtech side of things. So I don't know if anyone's familiar with Moodle, but Moodle is the main kind of driver that drives Irish colleges. So students get access to resources, all that sort of stuff. Moofwd operates similar kind of concept and technology within South America. The only difference being, so within Ireland and across Europe, the majority of universities are actually public, whereas the majority of universities within South America are actually private. And the colleges are extremely big. So there's one particular college that has over 250,000 students. So one of my main kind of projects at the moment is resource management on servers. So can we predict AI? Can we predict traffic oncoming onto servers? So there's obviously busy periods when semester starts, be it in September, August, whatever, and obviously in the new year as well, with January, and then there's obviously quiet terms over the summer as well. So essentially, I'm currently building an AI that actually manages the resources on servers. So can we predict when there's going to be an oncoming a lot of traffic, and judging by the result of the AI, we increase or decrease resources of the servers. Not only that, we kind of wanted to create kind of a more secure environment. So I've also created an AI that actually detects anomalies. So if there's anything funny happening on the servers, we've actually created an AI that does that too. Then there's another project where it's on the fintech side of things. So there's obviously the big trend nowadays, the generative AI and LLMs. But what I find is when talk to most multinational companies is that there's sort of a kind of a hesitancy when integrating LLMs. So obviously due to privacy reasons, companies don't want to share confidential information. So they're piloting Gen AI kind of stuff. So my role is from a consultancy and developing background is essentially trying to create a custom LLM that allows companies to use generative AI. And not just the standard kind of regular ones that are used to, like OpenAI, ChatGPT, Gemini, and all sorts. So yeah, they're the current projects I'm working on at the moment. And so that's Mark here.
Yeah, so tell me tell me a little bit about your PhD and the kind of grounding it gave you for solving different types of problems, because in the world of academia, when you're doing a PhD, like it's a big result even just to finish it, right? But sometimes you're left with, well, where do I go now? How do I actually start to apply this to everyday types of problems? And I appreciate you're kind of talking about that kind of anomaly detection. You talked about allocation of resources, getting ahead of it from kind of forecasting, and then some integrations for generative AI and how that could be done. Tell me a little bit about that PhD and also some of the kind of projects that have now inspired you within solar?
Yeah, absolutely. So like it's my PhD is the main thing that actually got me into AI. So from my PhD essentially was on a high level kind of note was integrating AI within solar physics. So just on that, from going from solar physics to a business standpoint, they're exact same similar concepts, just dealing different forms of data. So just a bit of a background on my PhD. So essentially, my PhD involved detecting and predicting solar weather on the sun. So when I talk about solar weather, I talk about solar flaring activity, so essentially large explosions on the sun. And this was essentially the way we kind of approached it was we used a radio telescope known as LOFAR, located in Birr Castle, County Offaly. So it's not just a single station. There's 52 stations across Europe. It's a wide project across Europe, and they're just recently starting to get into the AI kind of thing. So my PhD was about 5 years ago started, and at the time there was no real AI integration within not only solar physics but just space in general. It was only starting to become a big thing, and the current at the time the current kind of approach was to use standard classification techniques to detect solar weather. So specifically, if you're looking at solar weather, there's two ways of looking at it. There's from a radio scale, and then there's an imagery scale. So an imagery scale would be you see a nice perfect picture of the sun, and you see obviously different activities going on. Whereas on a radio kind of scale, it's more abstract. So essentially, what the kind of best way I can describe it is like a heart monitor. So they're signals essentially. And the two specific types I kind of focused in on, the two main problematic types, were what's called a type 3 radio burst and a type 2 radio burst, solar radio burst. So essentially, there's a lot of problems with the two. Specifically with the type 3, these occurred every 1 to 10 seconds. So these were extremely fast. So essentially, we need an algorithm that could predict in real time. And then on the other side of things, the type 2, they didn't occur as often, but their shape was just absolutely abstract. If I was going to describe it, it was like throwing paint on a blank canvas, completely random, and it's basically like a big massive splash. So these are two different problems we had, and prior to when I came into my PhD, I never even looked or heard of solar physics before. So essentially, we kind of took it as just look at the data. Just how do we solve this from a data standpoint rather than looking into the finer details of solar physics. So we looked at a few papers around at the time, and as I said before, that a lot of papers focused in on the classification side of things. So was it essentially, are we answering yes or no? Is this type 3 or is this type 2? There was no essentially details, and it couldn't really be done in real time. So the main focus for me was, can we actually do it? Can we apply AI to this telescope and predict in real time? So we kind of, rather than looking at it from essentially a classification standpoint, we looked at it from an object detection standpoint. So object detection is essentially how a computer sees people, pedestrians, and they're often used autonomous cars, all that sort of stuff. So we essentially took that model. It's called YOLO. And it stands for you only look once. And at the time, my kind of first standpoint for the first 2 years of my PhD was creating a custom model to detect. So obviously we took a model designed for detecting humans, vehicles, essentially everyday items, and we actually fine-tuned it to detect solar weather. And it's come on a lot, so I think we're at YOLO 11, so it's iterated quite a number of times. But back then, you essentially had to delve deep into the model to essentially fine tune it for this specific task. So my first iteration, which is my first paper that came out, when applied to the data, we got an accuracy of, I think, was 77%. So it was good. It was good, but we felt that it could be improved. And at the time, it only came out that the generative AI, but from an image standpoint, recent research came out within that. So there was a significant problem. Okay, we got 77% accuracy, but it was only on a test set. So when we applied it to actual new oncoming data, like from a different day or different, because a lot of days were different compared to solar weather busyness, if you're going to call it that. it wasn't robust enough. So we essentially wanted to address the training set to make the model more robust. So one of my significant papers from my PhD was we implemented this kind of a simulated data set. So data set that was fake but looked real. So what we did was we used an algorithm called generative adversarial network, or GAN for short, to create a simulated data set that would be kind of, it would look like the real thing, but you could still see that it wasn't real. So we essentially then fed this back into YOLO, and then we achieved an accuracy of, I think, 85%. But it was an 85% that was actually significant. It was how robust it was. Because we had a significant issue with what's called radio frequency interference, and it's like someone getting a nice picture and then just started to color over it. So essentially, it's inhibiting the model's detections. So with the new kind of approach we with the simulated data set we took was it made the model more robust, and that 85% accuracy was across new oncoming data each individual observation day. Just on then, so that was a significant paper within my PhD, but then we had to turn to the type 2s. Now, type 2s aren't as quick, but when they happen, they have significant impacts on our Earth, our beloved planet. So basically, type 2s are associated with coronal mass ejections, and a coronal mass ejection is essentially a massive explosion on the sun. And when I say massive, I mean these can be like numerous times the size of Earth. So just to give you a bit of context, so the sun is 1.3 million times the size of Earth. We are a little speck when it comes to when we're put side by side. So
cannot get over that size ratio. That is incredible.
It's
Why have I underestimated
it's
that?
crazy.
That's incredible. That is truly incredible. So when that explosion happens, and I've kind of cut across you there, so
Yeah, no problem.
I'll let you. So that explosion happens. How do you even know it's happening?
So basically, there's signs. So the Earth, not like like the sun, not like Earth. So Earth has a north and south pole kind of magnetic field, whereas the sun is basically like I always describe it like this. It's a bit funny, but it's like getting a bowl of spaghetti and you're starting to turn it. So the more you turn it, the more spaghetti snap essentially. And when these snap, the magnetic field eject mass amounts of charged particles or radio emission. These have significant effects on Earth. So if a large one hits, we have astronauts in this, above in space. It significantly affects GPS, and it's all okay, as in you might be lost for a bit, but if you're on a plane and you lose GPS signal, that's a significant issue. Then there's if a really large one hits, then it can actually fry electrical transistors and force essentially power outages. And if a really large one hits, it can essentially send us back into Stone Age for about 6 months. So these are significant. Now, one thing we have with radio astronomy specifically, and with satellites, not only operated by NASA, but European Space Agency as well, and also LOFAR, is that once there's signs that prior to when they occur. I just talked about the magnetic sign, but with the radio emission, so it takes about 4 to 5 days to actually reach Earth prior to when the event happens. Okay, so we've essentially time to prep. And what allows us these time to prep is these detection models, these brand new AI models coming in that are being applied to these telescopes. And with that, we can detect and we can prepare essentially for these oncoming events, and essentially turn off anything that has electrical, essentially prepare for what's to come. And I think there was, I don't know if anyone's familiar, but there was 2 Northern Lights occurrences there. One May specifically, and actually just recently there, about a couple of weeks back. They are a resulting event of a solar storm essentially. So you can actually see an effect on what I'm talking about from a sky standpoint.
So when you, and again we can all relate to that, to those Northern Lights. So when you take all your knowledge and all those insights and intricacies that you kind of get accustomed to, how do you then start to apply it to real world problems for impact from a business perspective?
Yeah, absolutely. So what I always say is the models don't change, the AI doesn't change, it's the data that changes. And as I said, from prior to when I started my PhD, I was unfamiliar with the solar physics, kind of the whole idea of solar physics. But I knew had a bit of knowledge on AI computer vision. So when you're looking at it from a business standpoint, the models don't change. So the models you're applying don't change. Okay, maybe the methodology of the models or what you're trying to achieve doesn't change. But the data and how you prep it, you're still using the same standards as you would from using be it in solar physics to a business standpoint. They're shared concepts essentially. You're just dealing with different data.
And that's a really, really good thing to say, because sometimes within industries, people can get fixated on, well, it's not finance, it's not healthcare, it's not applicable to me.
Yeah.
But so many of the use cases, all it is just different data.
It's
So
essentially just different data.
Yeah, just different data. And you can get so bogged down. Now, I appreciate there's different compliance in healthcare or finance, but still, it's just the different data, and you're just actually just swapping one for the other. So with so many different things trying to change or move at the moment, it's the infrastructure in AI is changing dramatically in terms of the cost of compute. Then you've also got these so many different generative LLMs coming onto the market from so many different types of providers. When you're looking to do the different kind of projects internally that you focus on, are you sticking to Llama? Is it OpenAI? Is it Microsoft? Is it how do you determine the different types of tools you're using?
Yeah, so from essentially, as when I started off, there's from talking to a few multinationals on the consultancy side of things, there's a lot of hesitancy. Especially if you're one single entity company and you're sharing your knowledge with a Llama, confidential knowledge with a Llama mod, sorry, not Llama model, Copilot, OpenAI. There's a lot of hesitancy with it. So you're essentially sending your data to external sources when you probably don't want to do it, and a lot of companies don't want to do it. And they're very, very. I wouldn't say they're not fully embracing the Gen AI. They're kind of starting to come about to embrace it. So what I kind of look at it from the first standpoint is what can we do and how can we navigate through these policies or guidelines that this specific company has addressed. So one particular company I'm now working with have set a specific guidelines. As I said, they're very, very hesitant at applying generative AI within their industry. And it's essentially trying to navigate through the guidelines. So can we create a model or fine-tune a model, even as you mentioned Llama there. So Llama is an open source LLM, but it can be fine-tuned to a specific data set. And it can be stored and it can be hosted locally as well. So these are the kind of questions you have to ask when addressing these. So kind of when I first approach a company, is in what are your guidelines? What are the specific laws you've set to engage and embrace this generative AI? And then through that, you can actually navigate through the data. So the model only comes into play when it comes to accuracy and the accuracy of the answers it's generating. But it all starts with the data. So what has the model been trained on? Has it been trained on open source models data sets? And can it be fine-tuned or altered to your specific needs, essentially? So that's what kind of...
And I totally appreciate the hesitancy and the kind of guidelines, making sure. But what we're kind of seeing from a lot of organizations is just a missed opportunity where they're just kind of stuck in the mud. They're not going to make a decision. They're kind of waiting for a perfect time, and consequently, projects are either probably getting shelved, or they're not necessarily getting fully the kind of commitment. I'm guessing from a holistic point of view, you're probably spotting opportunities for companies to go ahead and actually just not making. They're not taking the opportunity while maybe their competitors are.
You literally just said it there, Mark. Like there's a significant opportunity. So there's one specific multinational I'm working with that they're just not embracing it at all. There's no policy on using for coding, and from a project standpoint, it sounds crazy. Like you're extending deadlines and essentially falling behind what the other companies are essentially doing. So if the companies are embracing it, they're getting projects done in like 30-40% like quicker times rather than not embracing it, and you're essentially stuck in a rut, as you said.
Yeah, and what we're seeing is this technology has gone to consumers first. So usually it would be enterprise. Well, the mindset of years ago is enterprise first, then roll it out. But now employees are coming to the table, digitally native. They're using these tools themselves, And then when I go into an organization that can't use them, they're actually just thinking, well, this is kind of like pushing paper. What a missed opportunity to kind of empower or engage your people, right? And and I see it as a really good way to attract people, retain people, but also, employees know if they're not working on AI in some capacity of their work or how they're approaching their work, they're less likely to get a job in the future.
Absolutely. And like it's become such a diverse topic. So at the start, like a couple of years ago, as in if you're talking about AI, you're just talking about a coding standpoint or software developer standpoint. Whereas now, like you can get qualifications in marketing within AI or sales within AI. So it's become such a diverse topic, and it's going to be more integrated, not only from a coding or software standpoint, for all aspects of company pipelines in general.
Yeah, absolutely. You've been listening to the AI Ireland podcast. My name is Mark Kelly, and part of the Young AI Role Model of the Year award, I've been speaking with Jeremiah Scully, who's a finalist for this year's award. He's an AI R&D engineer at Moofwd, and Jeremiah's been talking a little bit about some of the work that he does there and what he's done in his PhD about applying AI to solar physics. We also talked about his innovative solution for solar weather detection and manufacturing quality assurance. Jeremiah, thank you very much for your time today.
Thanks, Mark. Thanks for having me.
Membership of AI Ireland places your organisation at the centre of the fastest growing technology sector in the world today. As a member, you'll have access to our diverse and highly engaged professional community, which is committed to driving artificial intelligence forward in Ireland. Membership of AI Ireland is for any organisation employing data and analytics. We offer memberships to corporate, government and SME organisations. Interested to find out more? Contact Mark at aiawards.ie.